Hello, students of grade 7. Today our science lesson is about the atom. Please watch the video in the online task slide and complete the questions. Read the summary written on each slide. Watch the videos on slides number 5, 6, and 17. Complete the questions on the slide in the areas provided and do the online assessment on Edmodo after completing the lesson. So how do we know what parts make up the atom? By the end of this lesson, you will be able to describe the way in which atoms make up matter. You will be able to describe scientific contributions to atomic theory. You will be able to describe the current model of the atom and state the location, charge, and relative mass of protons, neutrons, and electrons in an atom. So first, please watch the video found in this link and answer the following questions. What is an atom? Who proposed the idea of an atom first? What are elements and what are compounds? What makes up matter? Please also watch the video right here that will explain to you everything in details. All matter is made up of atoms. Atoms are the smallest particles into which an element can be divided and still be the same element. You cannot see individual atoms. As we talked about before, that atoms here are the building blocks of life. So everything in life is made up of atoms, and they're the very small particles that we cannot even see individually. We only see them as objects or elements. So on page 459, you will find a picture and a question at the bottom that asks you to look at the image right here and what can you infer about atoms from this image and what can't you infer from the image. Keep in mind that this image is carbon atoms that are connected together. It was taken under the special type of electron microscope. So, the atomic theory. The first scientist or the first chemist that proposed the idea of an atom is called John Dalton in 1808. His theory said that all matter is made up of atoms. Atoms cannot be created, divided, or destroyed. Atoms of a certain element are identical, and every substance is made up of atoms combined in certain ways. So we all know that atoms are the building blocks of life, so that makes sense. Atoms cannot be created, divided, or destroyed. Well, since atoms make up matter, and we know that the law of conservation of matter states that matter cannot be created nor destroyed. Atoms of a certain element are identical. For example, if we think of a copper wire, this copper wire is only made up of atoms that are copper atoms, and every substance is made up of atoms combined in certain ways. Well, for example, if you think about water, we know that even though water is made up of two different elements, each water molecule is identical and has only two hydrogens and one oxygen, which means that they are chemically bonded together, making up one water molecule. The second scientist talking about the atomic theory is J.J. Thomson in 1897. His experiments provided evidence that atoms contain negatively charged particles, which were later called electrons. Now, Thomson thought that an atom was a positive sphere with electrons mixed through it. So this is what he proposed the idea of an atom is: one large sphere containing electrons and positively charged particles inside it. So, based on the following information, describe how you would show J.J. Thomson's model of the atom using small beads and clay. You will find this question on page 160 in your book. So, the third scientist talking about the atomic theory is Ernest Rutherford. In 1909, Ernest Rutherford's experiment suggested that atoms have a nucleus. We all know that a nucleus is a small dense center that has a positive charge. Now, later on, he found out that the nucleus has positively charged particles called protons. The last scientist that talked about the atomic theory is Niels Bohr. He suggested a model in which electrons move around the nucleus in circular paths, with each path at a certain distance from the nucleus. So he suggested that this is the nucleus that has the protons, and that the electrons that travel around in paths around the nucleus. So based on the following information and using pages 160 and 161 from your book, please solve the table below. Differentiate the four atomic models based on Dalton, Thomson, Ernest, and Bohr's models. What is the current atomic theory. Now, in 1932, James Chadwick discovered that the nucleus contains uncharged particles called neutrons. In the current atomic theory, the electrons, however, do not move in circular paths around the nucleus, just as the scientist Niels Bohr thought. However, the current theory suggests that electrons move within an area around the nucleus called the electron cloud. So based on the following information, please label the diagram of the atom below. And please solve the question on page 161 that says, today's model of the atom looks different from the models that came before it. Why has the model of this atom changed? So what are parts of the atom? You can watch the video here that explains each part separately and in details. But we know that atoms are made up of protons, neutrons, and electrons. The protons are the positively charged particles that are written as 1 plus. So if we have one proton, we are writing it as 1 plus, and it has a unified atomic mass unit. The mass of a proton is about 1 unit. The neutrons are particles that have no electrical charge. The mass of a neutron is slightly more than that of a proton, but is still close to 1 unit. Most atoms contain at least as many neutrons as protons. So, together, the protons and neutrons, they form the nucleus of the atom. And because the neutrons have zero electrical charge, they have no electrical charge, the protons are positive, so the overall charge of the nucleus is equal to the charge of the total number of protons. The negatively charged particles of an atom are called electrons. The charge of a single electron is represented as 1 negative. It is not possible to determine the exact position and speed of an electron at the same time because they are constantly moving in their electron cloud. Therefore, we could picture the electron as being in an electron cloud around the nucleus. Now, compared with protons and neutrons, electrons have very little mass. The number of protons and electrons in an atom are the same, so their charges are balanced and the atom has an overall charge of 0. An atom can gain or lose electrons to become an ion, which has a net positive or negative charge. So in normal conditions, the protons and neutrons are not the same. However, the protons and electrons are the same and they have the same overall charge, and therefore the atom has an overall charge of 0. So based on the following information, please answer the table below. So how do we describe atoms? Different combinations of protons and neutrons and electrons produce atoms with different properties. The number of each kind of particle within an atom determines its unique properties. These different atoms combine to form the different substances all around us. So we have different chemical bonds that combine these elements together in atoms to give us different substances around us. So the number of protons distinguishes the atoms of one element from the atoms of another. So the number of protons in the nucleus of the atom tells us the atomic number of the atom. So looking here at the image right here, this is boron from the periodic table of elements. Boron has an atomic number of 5 and it has an atomic weight of 10. Its symbol is B, and this is its electron configuration, and its name is boron. So based on the following information, what does the atomic number tell us about the number of protons and the number of neutrons? Please type your answer here. The atoms of a certain element always has the same number of protons, but the number of neutrons may differ. Isotopes are atoms of the same element that have different number of neutrons. Then total number of protons and neutrons in an atom's nucleus is its mass number. So in normal conditions, the protons are equal to electrons. However, each element has a specific atomic number, and the atomic weight gives us the number of protons and neutrons together. If we want to have the same element but with different number of neutrons, that would be called an isotope. So based on the following information, please label the following diagram. And please answer this question on page 164 that asks you, how are two atoms of the same element alike? Also on page 165, use this model of a helium atom to find its atomic number and mass number. Please type your answer here. Thank you for listening. Stay safe, grade 7, and have a great day.